Okay, so we're going to start off by talking about some initialization techniques, and namely the Glorot and I'm not sure how to pronounce the second one. We're going to go with he, but I'm almost sure that's incorrect. Okay, so we require the signal to flow in both directions, forward in making the predictions and backwards during backpropagation. And we require that the variance of the inputs are equal to the variance of the outputs, so we don't have the saturation problem. Similarly with the gradients, we want the variance to be equal between the inputs and the outputs. If you think about a microphone and an amplifier, if you want the volume of the amplifier to be equal to the volume of the input into the microphone, then you want to make certain adjustments. So this works. Okay. So under some compromises, we can make an initialization that is close to this idea, which is called Xavier initialization. And Xavier is the first name of Glorot. His name's Xavier Glorot. He was one of the people that came up with this. And this turns out to be extremely efficient. So different initialization strategies should be used according to the activation function used. And this next slide is very useful, and it's a summary of which ones you can use. So the Xavier initialization works for the activation functions tanh, logistic, softmax, and even no activation functions. And the he would be for ReLU and ReLU variants, which we'll talk about soon. And LeCun, you use the CeLU, which is even more useful, and you'll see why soon. But the variance for the normal case is equal to these terms on the right hand side of the table, and you can look at the what they mean here below. So how do we change the initialization in Keras? So for the he initialization, for the ReLU invariance, as you can see, this is what we use. We just add it inside the specific layer that we want it applied to, and it goes under kernel underscore initializer. And for this one, we're using he normal, because this is the one applied for the ReLU activation function. If you would prefer to use fan average instead of fan in for the denominator, you can also change this if you want to use it in conjunction with the uniform distribution, like this, where you first specify the variable and then you add it into the dense layer, so it looks nicer basically. Okay, just a quick quiz. Write down on a piece of paper the code for a dense layer with 64 neurons, tanh activation function applied, and the appropriate initialization technique for the tanh activation function. See if you can remember which initialization technique that is. If not, have a glance back. I'll give you a second to pause the video. And the answer, this is the answer here. Okay, see you in the next video.